Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the problem on curved surface submerged in the liquid. In our previous lecture, we have already discussed the theory part of this curved surface when it is submerged in the liquid. So today's lecture, we'll discuss one problem related to this. So I have considered a problem, compute the horizontal and vertical component of the total force acting on a curved surface AB, which is in the form of quadrant of a circle of radius 2 meter as shown in the figure, and take the width of the gate is as a unity. So here one diagram is given, and based on the diagram the question is given that we need to find out that horizontal and vertical components of the total force acting on the curved surface. So this is our curved surface is there, AB curved surface. Okay, and this curved surface is situated as per the diagram it is given. This is the free surface of the liquid. Okay, and from this free surface of the liquid, this curved surface is situated with a height of 1.5 meter. Okay, and the distance, or we can say the radius of this curved surface, if you consider this is the center point of that, and we can say this is the radius of 2 meter. That means we can say, if you consider this is the point of O, and from here to this point, this is the height of 2 meter. Okay, and from the free surface to this center point of this curved surface, that is with the height of 1.5 meter. So let write down what are the data is given here for this question. So we can write first one, the width of the gate as unity. Okay, so that is W we can write here, we can write that is W equal to 1 meter, and similarly the height of this we can write this one. Okay, so that radius, or you can say the height of OB also, that is the same thing, this is 2 meter, or this one also you can write the distance from this O point to B point, or you can say the distance from from A to O, because this is the radius is given, so the distance from A to O or O to B both will be same. So we can write AO, or we can write OB equal to same 2 meter. Okay, so these are the data are given. Now we need to find out what is the horizontal pressure force. First one we will write what is the horizontal pressure force acting on that. Okay, acting in the x direction. Okay, so the horizontal pressure force, which is Fx, exerted by the water on the gate. So let's see, this is the Fx is there, that means this is the horizontal force Fx, which is exerted by water on the gate. Okay, and this one we can write, we know that previously actually, that is Fx equal to, in the previous equation we have already got this one, we know the Fx equal to, we can write the total pressure force on the projected area. Say this is the projected area of what? Projected area of this curved surface. Okay, this of curved surface AB, this one. Okay, AB on vertical plane, so we can write this one. We know that the total force equal to see, this is the total force on the projected curve area, the total force, this horizontal force on the curve area. Okay, and curved surface AB, and that to be on a vertical plane, that means that is nothing but OB. Okay, so we can write this equal to, also you can write the total pressure force on OB, that is the vertical plane is there, so we can write this one. So we know the formula here for this, equal to rho g AH bar. Okay, rho g AH bar. This one, the formula already we got previously in the theory, in the previous lecture, in the previous video, you can see that one. Okay. Now here we can find out the, we know the density of this liquid. Okay. That is what we have considered. Okay. Water. So density of the water, rho equal to 1000 kg per meter cube. And G, we know that 9.81. And area we can find out this one. Area is nothing but the height and width what is given, so that we can multiply, so that is nothing but 2 into 1 2. And this h bar we need to calculate here. The h bar, that is nothing but we can calculate, that will be h bar equal to this center point of this curve line, okay, or the distance from this free surface to the center of gravity of this point. So that is actually, we know total height how much is present from this free surface, so that is 1.5, and the height of this curved surface divided by 2, half of that, so that is 2 by 2 you can say, and we'll get here 1000 into 9.81 into 2 into 1.5 plus 1, that is 2.5. So we'll get this. Okay, so by this we can calculate, if you calculate this one, we'll get 1000 into 9.81 into this is 2 into this is 2.5. So this is near about 49,000. Okay, so we'll get 49,000 Newton. So this is the force in the x direction, in the horizontal direction. Okay, now we'll find out the point of application in the H star or Fx point. The point of application, that is the point, the pressure, the center of pressure we can say. Okay, that is nothing but the H star. Okay, so we know that H star equal to, how to find out the H star? Okay, we know the formula, that is nothing but Ig divided by AH bar plus H bar. Okay, so H bar already we have got this value, H bar value, area we know, and Ig only need to calculate. Okay, so the Ig is nothing but the moment of inertia. Ig is nothing but the moment of inertia, okay, of which point? Of the OB, of OB about its center of gravity will be there. Okay, about its CG, center of gravity. So that one we can write B dq by 12. B dq by 12. So here B dq by is nothing but B1. Here depth is 2. Okay, this is the depth 2. Width is 1, and 2 to the power 3 divided by 12. So 2 to the power 3 is nothing but 2 to 4, 4, 8, 8 by 12. So 8 by 12 nothing but we can write 2 by 3. So 2 by 3 meter to the power 4. This is your Ig value. Okay, and here Ig we got here 2 by 3. That write down 2 by 3. Okay, and area already we got there 2 into H bar 2.5 already we got here previously. See this one 1.5 plus 1 and plus 2.5. So if you solve this one, you get near about 2 by 3 into 2 into 2.5. Okay, plus 2.5. Now 2 will be cancelled here. So 1 by, we can get 3, 2.5, that is 6, 1.5, 7.5. So 1 by 7.5. So that will be nothing but very small value will get, 0.01 something will get. So let me write just a 0.13 near about plus 2.5. So if you add this one, we'll get 2. How much? 63. So 2.63. This is the meter from the center, from the free surface of the water. Okay, so this is the H star value. Okay, the center of pressure of the point. Now we need to find out the vertical components. Horizontal components we have already identified. For vertical components, okay, we can write vertical components. The vertical components we can write the Fy equal to, we know that we can say the weight of the weight of water supported by AB. The weight of water, the total weight of water supported by this curve, this is the curved surface, so by AB, okay, up to, you can say, the free surface. That means the total water which is present in this zone, so that is supported by this curved surface up to the free surface. So that is nothing but a vertical component which is acting. That equal to, this one we got already in the previous our lecture. Now, so now what I can write here? So Fi equal to, also I can write this one, I can write weight of the, what is the weight of that particular portion. If you see from here to here, let me use another one. Now see, the total weight will be like, from here to this total, okay, this total surface should be there. So now what I can write here, this is the weight of which portion? The portion of dA BOC, this full portion we can see there. Now see, dA, this part dA BOC. Now we can see this is one part and this is one part. Okay, so what I'll do, I'll just split it into two parts. So one is, the weight of, DAOC plus, now see, DAOC plus one thing, the weight of another part is there, that is, we can write AOB, that curve part actually, AOB, this part. Okay, so these two part we can write here. So now we can write this weight of this DAOC and weight of AOB, that we can write a formula rho g, okay, rho g into the volume, because we know that W equal to mg, okay, and here I can write this m equal to rho v into g, because we know that density equal to mass by volume, and so we can write m equal to rho into v, so density volume g. So for this also same and this also same will be get. So what I'll do, I'll take this common of rho g from both of the values, both of the formulas. So finally what will get, volume of this, so that is nothing but volume of DAOC plus, again same thing here, the volume of which one, that AOB point. So both volume we need to write now. So we can write this rho g, this is the volume of this one, we can write, how much is there, that we need to check it once. AD height is there, and this one length, AD into AO into the unit weight. Okay, this is the one side. Now this side, volume of AOB, this part, this volume what we can write, okay, so we can write here pi by 4 into the r square into the width. Okay, so this one we can write here. Now what I'll get here, rho, I'll get here 1000, 9.81. AD value how much is there, 1.5. AD value is 1.5, and AO I hope 2, and this is 1, and this is pi by 4 into 4 into 1. So this 4 will be cancelled, and here I can write 9810. This is 3, so 3 plus, and this is pi, let's write pi. So what we'll get here, so let's write this one, I hope get this 9810 into 3.14, this is 3, 6.14, let's see, 60,000, 233, we'll get 60,233, which is Newton. Point some value will be there actually, So that is our the component, the force component in the y direction. Okay, this is the vertical component, and the horizontal component already we got here, this one 49,000 near about. So like this we need to solve the problem when this is given a curved surface submerged in the liquid, and because this formula already we have discussed previously, so that's why I written directly, or else we need to remember what the procedures are there to identify these formulas. For that you can refer the previous lecture. I hope you understand how to solve the problem on the curved surface when it is submerged in the liquid. So if you are having any kind of doubt regarding this, you can give a comment in the comment box. Thank you all.